Hello, IGCSE Physics students. Welcome back to the channel. In this video, I am going to discuss Cambridge IGCSE Physics Paper 2, multiple choice questions, which is extended paper. The paper that I'm going to discuss is May, June 2025, paper 22. Are you ready? Let's get started. Now, let us begin with the first question. Number one, which instrument is most suitable to determine the volume of a small, irregularly shaped stone? Now, if you want to determine the volume of the small, irregular, so small is the keyword, and it is irregularly shaped, right? The best instrument to be used is your measuring cylinder, right? Because this is to measure the volume. So how do you do it? Initially, you just prepare a measuring cylinder. You just fill in water into your measuring cylinder, and then you take its initial volume. After that, you carefully place your small irregularly shaped stone into the measuring cylinder. And you definitely know that the water level is going to rise up. So you take its final volume. So the difference between the two volumes, the final and the initial volume, will give you the volume of the small irregularly shaped stone. Right, 30 cm ruler is used to measure distance, small distance within the 30 cm or the height within 30 cm. Digital timer is used to measure time. Tape measure is used to measure distance which is more than 100 cm. So that is the reason why the answer is C. Number two, a steel ball is dropped from a top floor of a building. Air resistance can be ignored. I need to highlight this. Air resistance can be ignored. You see this word? Which statement describes the motion of the ball? When the air resistance is being ignored, you need to understand that the steel ball will fall with the only force that acts on it, which is the gravitational force. The only force that acts on the steel ball is the gravitational force, which gives the steel ball gravitational acceleration. And the value of the gravitational acceleration is constant, which is 9.8. So that is why the ball will fall with constant acceleration. Or you say that the speed of the ball increases constantly, uniformly. That is why the answer is A. Number three, the diagram shows a velocity time graph for an object which is accelerating. What is the acceleration of the object? Could you see the graph? This is a velocity time graph. To find the acceleration, you need to find the gradient. Gradient is equal to acceleration. So gradient, you need 2 points. I take this is my first point as my first point, 0, 20. And the next point is 40, 120. So the gradient, still remember how we find y2 minus y1 over x2 minus x1, which is equal to your acceleration. So I take 120 minus 20 divided by 40 minus 0. This is 100 divided by 40, which is acceleration. Acceleration is equal to 2.5 meter per second square. The answer is B. The next one, number 4. Diagram 1 shows a piece of a flexible material that contains many pockets of air. Diagram 2 shows the same piece of the flexible material after it has been compressed, so that its volume decreases. To the mass and to the weight of the flexible material when it is being compressed. After all, the difference between diagram 1 and diagram 2 is diagram 1 is before the flexible material is being compressed. Diagram 2 represents the flexible material after being compressed. So it is the same material. So that is why the mass of the material must be the same, because it is the same of material. It's just that the volume has changed, right? When there is no change in the mass, the weight is equal to mass times gravitational acceleration. Gravitational acceleration is constant, which is 9.8 meter per second square. So mass is constant. That is why the weight must be constant as well. No change in weight and no change in mass. Number 5, a student determines the density of copper. She has a rectangular block of copper like this maybe. Okay, this is the rectangular. Okay, I'm bad in drawing. Okay, just like that. Rectangular block of the copper. Which other apparatus does she need? Density is equal to mass over volume. To find the volume of the rectangular block, all I need to do is just to take my meter rule to measure the length, the width, and the thickness. Length, the width, and the thickness. So I can use a ruler to measure. So I need a ruler. And I don't need the stopwatch. I don't need the stopwatch. I don't need thermometer because stopwatch is used to measure the time and thermometer is used to measure the temperature. I don't need that. I need balance because I need to measure the mass of the copper. So I need balance and I need the ruler. C is the answer. Now, number 6, a 0.15 kilogram mass is suspended from a vertical spring. The mass is pulled downwards until the spring has extended by 12 cm from its unstretched length. The spring constant of the spring is 30 Newton per meter. What is the magnitude of the initial acceleration of the spring when it is being released? I draw the whole situation for you to see. This is the spring being pulled down when there is a mass of a 0.15 kilogram. Right, so extension extended by 12 cm. So this is an extension, right? Extra length by 12 cm. So pull downwards, pull downwards. And then I let go of the force. What will happen? Of course, due to the elasticity of the spring, right? And the spring is still obeying Hooke's law, the spring will try to restore to its original length. So that is why the mass will be pulled up by, okay, and resultant force, a resultant force. That resultant force, okay, is actually from the spring. The force on the spring is itself. So you have to identify the two forces that are acting on the spring. So one is the weight of the mass downwards. The other one is the force exerted by the spring. Now, if you want to find the acceleration, do you still recall the equation of the acceleration? F equals to ma. But this F has to be resultant force. What is resultant force? Resultant force is the sum of all the forces that are acting on one object or one system. Resultant force in this case, F must be larger than W because once you release the force, right, the pulling force, the spring is going to pull out the mass upwards. So I would say outward force is larger than the downward force. I would say this is a force on the spring minus the weight of the mass is equal to ma. So I find my force on the spring first. Since this spring obeys Hooke's law, force on the spring is equal to kx. Weight of the object is mg is equal to ma. K is a spring constant. Extension is 12 cm. You have to convert to meter. So 12 cm, you take 12 cm divided by 100 minus mass of the object is 0.15 times 9.8 equals to, the mass is being pulled out, right? So the mass times the acceleration. So I'm going to do it one by one. 30 times 0.12 is equal to 3.6 minus 0.15 times 9.8. That gives you 1.47 is equal to 0.15 ampere. So 3.6 minus 1.47, you get 2.13 is equal to 0.15 A. A is equal to 2.13, 0.15 A. So 0 A is equal to 2.13 divided by 0.15. That gives you 14.2 meter per second square. So the answer is A. Round it off to 14 meter per second square. Number 7, a cricket ball of mass 0.15 kilogram. Oh, this is a cricket ball, 0.15 kilogram. It's moving at a speed. Okay, this is the initial velocity of 30 meter per second. The diagram shows a batsman holding a bat stationary as the ball hits the bat and bounces back at the same speed. Okay, this is the direction of the ball. The final velocity is also 30 meter per second, but acting in the opposite direction. Right, this opposite direction is the keywords, remember. I'm going to redraw it because this is too small. Now, this is the ball going with the initial velocity of 30 meter per second. And then after that, the ball rebounds with the same speed. The final velocity is also 30 meter per second. The ball is in contact with the bat for 1 times 10 to the power negative 3 seconds. The table shows the change in momentum of the ball and the magnitude of the force applied to the ball. Now, which row is correct? Change in momentum is equal to final momentum minus initial momentum. And before we sub in the values, I also need to remind you that momentum is a vector quantity. Directions count for the velocity. Could you see that these two velocities, one is moving to the left, one is moving towards the bat, and the other one is moving away from the bat. One is moving to the right, the other one is moving to the left. These are two opposite directions. Since you encounter with two opposite direction of the velocities, I will put positive to one direction. Normally, I will put positive to final velocity. Minus, okay, negative direction to the initial velocity. Now, safely sub in the values. Mass is 0.15. Final velocity is 30 minus 0.15. Initial velocity is negative 30. Now 0.15 times 30, that gives you 4.5. 4.5 minus negative 4.5. So you end up getting 4.5 plus 4.5. That gives you 9.0 kilogram meter per second. So your change in momentum is 9. What about the force applied? F is equal to ma. But I am not going to find the A. You see what happened here is that A is equal to V minus U over T. Still remember that? Now sub in the equation, you have M V minus U over T times in the M MV minus MU over T. Could you see that MV minus MU? This is a change in momentum that we have just calculated. So you don't have to double do, just put 9 divided by the time. 1 times 10 to the power negative 3, and you shall end up getting 9,000 Newton as your force. D is the answer. Number 8, a stone is thrown vertically upwards at a speed of 5 meters per second. Okay, this is the stone. I throw it up at the initial speed of 5 meters per second. All the energy initially in the kinetic store. Now, so this stone has initially kinetic energy. Is transferred to its gravitational potential energy when the stone reaches a maximum height. Maximum height. Which equation gives the maximum height h reached by the stone? Since the question already mentioned it all, I'm going to use the principle of conservation of energy to solve this. The total initial energy is equal to the total final energy. Initial energy of the stone is the kinetic energy of the stone, which is being converted to gravitational potential energy at maximum height. Kinetic energy is half mv squared. Maximum height gravitational potential energy is mgh. Could you see that? You don't really need the mass of the ball. So m and m, you can just cancel it off. I make h as the subject. H is equal to v squared over 2g. V squared is your speed, you square it. Your 5, you square it, divided by 2 times 9.8. The answer is C. Number 9, 3 energy resources are listed. Geothermal, wind, nuclear fuel. Which resources get their energy from the sun? Geothermal is not from the sun. Why? Geothermal is the energy from the inner core of the earth. It does not get the energy from the sun. Nuclear fuel. Nuclear fuel is actually from the process of fission of uranium. The splitting of a large nucleus to its fragments while giving out a large amount of energy. So that is why the only answer is wind. Number 10, a sample of a substance has a shape that is determined by its container. What are the possible states of this sample? It cannot be solid. Do you know why? Because the shape of the solid is fixed. It does not depend on the shape of the container. So say no to solid. Can you see the answer is quite obvious? B is the answer. Gas and liquid. Number 11, a stationary smoke particle is hit by a fast-moving nitrogen molecules. Which row describes the motion of the smoke particle and of the nitrogen molecule after the collision? So after the collision, because fast-moving nitrogen molecule is hitting the stationary smoke particle, so smoke particle will have to move. And what happened to the nitrogen molecule? Because nitrogen molecule is moving. So that is why I would say nitrogen molecules will rebound. So A is the answer. Now, number 12, a bubble of gas rises from the bottom of the lake. So this is a lake. So bubble is initially small. The table shows a reading of the gas pressure inside the bubble and the volume of the bubble. Temperature of the water in the lake is constant. The values in 3 rows of the table are correct and 1 row is not correct. Which row is not correct? Do you still remember one of the laws? Right, this is called Boyle's law. Pressure is inversely proportional to volume. So there is one equation related to pressure and volume. Pressure 1, volume 1 is equal to pressure 2, volume 2. So I am going to times the pressure and the volume to see what happens. Is that okay? Kilopascal, I'll just leave it here. cm cube, I'm just going to leave it there. So I take the first one, 360 times 2.4. Right, I got 360 times 2.4, and the answer that I got was 864 kilopascal cm cube. The next one, I take 270 times 3.2, and I got 864 as well. The third one, I take 160 times 4.6, and I got 1.6, 160 multiplies by 4.6, and I got 736. Last one, I take 120 times 7.2, and I got 864. Could you see that? So the value which is not tally with the rest of the value here is C. This is not correct. Number 13, the diagram shows a flask, a glass flask, sealed with a small volume of mercury in a glass tube. When the flask is gently warmed, the mercury rises up the tube. What is the main cause of the movement of the mercury? Okay, when the flask is being heated up, the air molecules will gain kinetic energy. Agree? When the gas molecule gain kinetic energy, they have more energy. They can move further apart from each other. So we say that the air inside the flask has already expanded and it moved up and pushed the mercury up. So that is why the answer is A. Expansion of the air in the flask. Number 14, the diagram shows the equipment used in an experiment to determine the specific heat capacity of a metal. In the experiment, a heater is switched on for T seconds, and the increase in temperature delta theta of a block of metal is measured in degrees Celsius. The power heater of power supply is given. So which equation gives the specific heat capacity of the metal? Don't worry, write down the equation of the specific heat capacity. I remember E equal to mc delta change in temperature. Make C as the subject. This is the energy or thermal energy. M times delta change in temperature. But the energy is not being given because we don't have the apparatus to measure the energy. But do you know how to relate? Do you still remember how to relate the power and energy? Energy is equal to power times time. So you just replace energy with power times time over mass times the change in temperature. So the answer should be PT M delta theta. C is the answer. Number 15, the diagram shows 4 rods. Each rod is made of a different metal. Wax is used to attach small metal balls at the rod ends PQRS. This is where wax is being attached to the small metal ball. Now, each rod is the same size. They are heated uniformly by a Bunsen burner at point X, the other end. As the rods warm up, the wax melts and the balls will fall off. Why does the ball on the silver rod falls first? Why? Because silver is the best conductor of heat. Do you know why? Because it can transfer the heat quickly to the end, which melted the wax and released the ball. Number 16, 3 solid copper spheres X, Y, and Z are heated to the same temperature. Which row gives the order for the rate of emission of radiation? Lowest rate of emission. Okay, I actually look from the back first. Diameter must be the smallest one because it cannot absorb that much of the heat, so it would not release a lot of heat. So I would say Y. And then second highest rate of emission. I'll look at the highest rate of emission first. Higher rate of emission, right? I would say that lowest rate of emission, it has to be, cannot be black color. It has to be white color instead of black. Highest rate of emission, diameter must be bigger and the color must be black. Why? Because black color is the best absorber of heat and the best emitter of heat. X is the best, okay, gives the highest rate of emission, right? The second highest should be Z. So B is the answer. Number 17, which wave will diffract the most when passing through a gap that is 0.85 meter wide? Right, so do you should remember about diffraction? A longer wavelength, it will diffract even more, will spread out even more. Diffraction is the spreading of waves when a wave passing through a gap. So I'm supposed to find a wavelength right here. So how to find a wavelength? Recall, the wave speed is equal to frequency multiplied by wavelength. Wavelength is equal to wave speed divided by frequency. So I'm going to use the wave speed. 300 divided by 280, and I got the value which is 1.07 meter. Second, 300 divided by 400, wave speed divided by wave frequency, which is equal to 0.75 meter. And the next one, 350 wave speed divided by the frequency, 280, and I got 1.25 meter. And the last one, 350 divided by 400, and I got 0.88 meter. So the longest wavelength, right, will give rise to the most diffraction. So C is the answer. Number 18, which arrow on the graph shows the amplitude of the wave? Amplitude is the maximum displacement from equilibrium position. Where is the equilibrium position? This is your equilibrium position. Why it is called equilibrium position? Because it split the wave into 2 equal heights. So the maximum displacement is B. B is called amplitude. Now, number 19, which row describes a seismic S wave? You have to do memorization here. You have to memorize. S wave is related to transverse wave. P waves is related to longitudinal wave. Transverse wave, direction of vibration is always perpendicular to the direction of the wavefront. How I remember? You write this, transverse wave. Can you see? I just put 90 degrees and I know the vibration of the particle is always 90 degrees perpendicular. Now, number 20, the image of an object is formed by a plane mirror. Which row gives the correct properties of the image? Image formed by the plane mirror is always virtual. Why? Because the image is always formed at the back of the mirror. And it has to be the same distance. Okay, let's say this is a plane mirror. This is the object. Distance between the plane mirror and the object is 10 meter. Distance between the image and the mirror must also be 10 meter. Right, so the same distance from the mirror as the object. D is the answer. Number 21, a ray of light traveling in air is incident on an air glass boundary. The angles between the incident ray, the refracted ray, and the boundary are shown. Which equation is used to calculate refractive index and of the glass? To calculate the refractive index, you have to understand is that when the wave is traveling from less dense air to denser medium, which is glass, you use psi incident angle over psi refracted angle. Psi incident angle. Incident angle is the angle between the incident ray and normal. So this is called incident angle. This is incident angle and this is a refracted angle. How do we get incident angle? Incident angle is your 90 degrees minus 50 degrees. And refracted angle is 90 degrees minus 64 degrees. So that is why it is psi 40 divided by psi 26 degree. The answer is A. Number 22, a small object O is placed near a converging lens as shown. The lens form an image I. Which statement is correct? I would say that it seems that the image is enlarged. Image is formed in front of the object, so the image must be virtual. Image that is being formed in front of the object, right? When the object is in front of the lens, image is called virtual. And the image is inverted. I don't see that the image is inverted because it is formed on the same side, same plane as the object. I would say that this is upright image. Upright image. The object O is closer to the lens than its principal focus. Yes, principal focus must be somewhere here. So the object is in front of the principal focus. D is the answer. Number 23, what is the approximate speed of light in air? Speed of light in air and speed of light in vacuum is the same, which is 3 times 10 to the power of 8 meter per second. Number 24, a ship sends an ultrasound pulse to the seabed to measure the depth of the sea. So this is a ship. This is a sea. Let's say this is a seabed. So the ultrasound is being sent to measure the depth of the sea. The speed of the ultrasound waves in seawater is 1,500 meter per second. The pulse takes 4.6 seconds. This is the time to travel to the seabed and back to the ship. Seabed, ship sent down, and then from the seabed going up to the ship to receive, so that the ship will know what is the depth, the real depth of the seabed, right? So the ultrasound is traveling to and fro. So that is why if you want to calculate the depth of the sea, V is equal to 2 times the distance over time. Because ultrasound pulse has to travel 2 times the distance, travel down to the seabed and then reflect up from the seabed to the ship. So speed of the sound, ultrasound 1,500 times 2 times equals to 2 times distance divided by 4.6 seconds. Distance is equal to 1,500 times 4.6 divided by 2. So the answer is 3,500 meter. C is the answer. I get 3,450, so I round it off to 3,500 meter. Right. Now, number 25. A dolphin has a range of audible frequencies of 150 Hz to 150 kilohertz. Which range of frequencies can be heard by both humans with good hearing and by dolphin? Humans with good hearing can hear 20 to 20 kilohertz. So, but 20, it cannot be heard by dolphin. So you cannot choose 20. You have to choose 150 hertz within the range of the healthy human hearing and 20 kilohertz. Yes, D is the answer. 26. A positively charged balloon is placed against the wall. The charge makes the balloon stick to the wall. Which statement explains this? Positive charges on the balloon attract electrons from the wall. It seems to be correct. B. Positive charges on the balloon attract proton. No, it meant to be repel. Like charges repel. C. Positive charges on the balloon repel electron. No, positive and negative opposite charges attract. D. Positive charges on the balloon repel protons on the wall. This is not correct. That is not the reason why the positive charge stick. The charges make the balloon stick to the wall due to the force of attraction. A is the answer. Number 27, a student is trying to determine the resistance of a lamp. He set up the incorrect circuit, which is true, it is incorrect, right? Which chain would allow him to make the measurement needed to calculate the resistance of the lamp? Resistance is equal to the potential difference across the lamp divided by the current. Ammeter must be connected in series with the lamp. Yes, but the voltmeter cannot be connected in series. Voltmeter has to be connected in parallel, two sides of the lamp. So the student needs to disconnect the voltmeter and connect it in parallel with the lamp. D is the answer. Number 27, 28. A metallic wire X has a resistance. What is the difference in resistance of a wire of the same material as X that is shorter than X but same diameter? Shorter length, lesser resistance. So smaller resistance. Same length as X but with a smaller diameter. Small diameter, thinner wire as compared to X, which is thicker. When X is thicker, it will allow more electrons to flow, right? So thinner wire, the resistance will be greater. C is the answer. Number 29, this diagram shows the circuit of a potential divider. Which equation is used to calculate V1? First of all, potential divider concept, do you should remember the output voltage over the total voltage, yeah? Is equal to the resistance which is connected to the output voltage over the total resistance. Now, I want to find V1, but hey, you look at the positive and negative terminal of the total voltage first. You check the positive terminal, negative terminal. Let's say this is 10 volt, for example. 10 volt meaning to say that out from the positive terminal is 10 volt and back to the negative terminal is 0 volt. If you want things to be easier for you, you always put the one that is connected to 0 volt as the output. So I'm going to connect this as my V output. So I'm going to write down V output over V total is equal to R output over R total. V output is my V2, V total is V1 plus V2. R output is the one that is connected to V output, which is R2. R total, because R1 and R2 are connected in series, so it is R1 plus R2. Now do your cross multiplication and make V1 as the subject. Cross multiply, this is V2, R1 plus R2 is equal to R2, V1 plus V2. Times in the V2, so I have V2 R1 plus V2 R2 is equal to times in R2, V1 R2 plus V2 R2. Make V1 R2 as the subject. Move shift the V2R2. V1R2 is equal to, okay, V2R1 plus V2R2, and I shift this positive, it becomes negative V2R2. Here, the whole thing here is equal to 0. So V2R1 is equal to V1R2. Make V1 as the subject. V1 is equal to V2R1 divided by R2. So the answer is B. Now, question number 30. Which electrical device is used to convert AC to DC? It is called diode because diode will only allow the current to flow in one direction. DC means that the current that flows in one direction only. Relay, the function of the relay is it acts as a switch to switch on the powerful circuit. Thermistor, so the temperature will affect its resistance. Transformer, to step up or step down the voltage. So that is why the answer is A. Number 31, a cell is connected to a parallel combination of 2 ohm and a 4 ohm resistor. The current in the 4 ohm resistor is 1 ampere. What is the current in the cell? Now I need to find the potential difference across these first. I use Ohm's law. V is equal to IR. I is 1. R is 4. So I have 4 volts. So the total potential difference or the EMF of the cell is also equal to 4 volt. Right. And now this is 4 volt. Right, because in parallel they share the same potential difference, and the potential differences are the same as the EMF of the battery or the cell in this case. So from here, I would like to find my current. So I'm going to find my current. V is equal to IR. 4 is equal to current times 2, and the current is equal to 4 divided by 2, which is 2 ampere. So here is 2 ampere. I want to find the current in the cell. Current in the cell is the addition of the current that split out or the current that flows through or the currents that flow through 2 ohm and 4 ohm. So the total current, I total, current in the cell means the total current is equal to 2 ampere plus 1 ampere. So the answer is 3 ampere. D is the answer. Number 32. When there is an electric current in a long straight wire, a magnetic field is created around the wire. Which diagram shows the correct pattern and direction of the magnetic field lines around a long straight wire carrying current into the page? So if you want to find a magnetic field around the current carrying conductor or wire, you use your right hand grip rule. This is my right hand. So the thumb represents the direction of the current, which is into the page. So your thumb point into the page and you grip it like this. So it is following the direction of the magnetic field is in clockwise direction. A, goodbye A, you are wrong. Now, B is okay. C, goodbye C, you are also wrong. It is between B and D. Why I cannot accept D as the answer? Because these magnetic field lines are closer. It cannot be closer when it gets away from the current. Why? Because the magnetic field depends on the current. Away from the current, the further it is away from the current, the weaker the magnetic field. So you have to draw the gap between the magnetic field lines are getting bigger and bigger. So that is why the correct answer is B. Number 33, the primary voltage supplied to a transformer is 3 volt. The secondary voltage is 5 volt and the secondary current is 2 ampere. The transformer is 100% efficient. You see this word 100% efficient? It also means that the input power of the transformer must be equal to the output power of the transformer. Input power is I times I primary times V primary is equal to I secondary, V secondary. I primary is given, which is V primary is given. I have to find the I primary. And I secondary is 2 ampere, V secondary is 5. So primary current is equal to 2 times 5 divided by 3, and I got 3.3 ampere. C is the answer. Number 34. When a thin gold foil is bombarded with alpha particles, some of the alpha particles are deflected through a large angles. Which statement explains this deflection? Okay, most of the atoms consist of empty space. When most of the atoms consist of an empty space, most of the alpha particles will just go through straight without deflection. So this is wrong. All of the positive charge and most of the mass of the gold atom are concentrated in a small volume. This sounds correct to me, but just going to prove C and D are wrong. Positive charge on the gold atom is spread evenly through the atom. This is not true. D, all the negative charge is concentrated at its center. No, negative charges or electrons are circulating outside the nucleus. So the answer is B. Number 35. A detector near a radioactive source shows a reading of 2,000 counts per minute. How is the corrected count rate determined? So the corrected count rate, you have to take the reading from the detector minus the background radiation. So you have to take away the background radiation. Number 36, which statement about alpha, beta, and gamma radiation is not correct? A, alpha particles are deflected most in electric field. It is not deflected the most, okay? I cannot agree with this, right? Because beta is deflected the most, because beta is lighter as compared to alpha. Alpha is heavier, it's hard to deflect. B, beta particles are deflected most in magnetic field. This is correct because beta is lighter. C, gamma radiation is not deflected by magnetic field. Why? Yes, because gamma has no charge and no mass. Right? Gamma radiation is least ionizing. This is wrong. It is actually most ion. Oh, this is correct. This is correct. Gamma radiation is least ionizing. Yes, correct. Because it has no charge. Okay, this is correct, not wrong. This is correct. So which is not correct? Which is incorrect? A is incorrect. Number 37. A sample of radioactive material has a half-life of 20 minutes. Which statement is correct? A, after 30 minutes, less than half of the material has decay. Okay, I would see after 30 minutes, this is, okay, I would say number initially is N. Time equal to 0. Okay, 20 minutes, it would decay to half of its original value, yeah? So this is one half-life, 20 minutes. And then after that, it would decay again to half of its initial value, divide 2. Divide 2, here you get N over 4. And then this is 2 times the half-life. This is 40 minutes, 2 times 20, this is 40 minutes. And then okay, N over 8, this is 3 times the half-life. This is 3 times 20, this gives you 60 minutes. And then decay, keep on decaying. Half, 16, this is 4 times the half-life. 4 times 20, this is 80 minutes. And then keep on, 32, right? This is 5 times the half-life, which is 100 minutes. And then decay again, 64, divide 2, yeah? This is 6 times the half-life, which is 120 minutes. Right, so these are all the remaining materials. Okay, let me see. These are all the remaining materials. So after 30 minutes, okay, 30 minutes is between 20 minutes and 40 minutes, less than half of the material has decayed. Actually, more than half, because, right, half is 1 over 2. And then after that, it keeps on decaying again. This is more than half. So this is incorrect. After 40 minutes, all the radioactive material has decayed. No. only 1/4, right, of the, okay, it says, not 1/4, 1/4 remained. So not all the radioactive material has decayed. After 60 minutes, 1/8, 60 minutes, let me see. So could you see here, this is 60 minutes, 1/8 of the radioactive material remains. This is definitely correct. After 120 minutes, a sixth of the radioactive material remains. No, 1/64. So C is the answer. 38. Which statement is correct? Right? Let us look at A. The Earth orbits the Sun once in approximately 24 hours. This is 335 days. This is wrong. B. The Earth orbits the Moon. No, it's not the Earth orbits the Moon. It's the Moon orbits the Earth. C. The Moon orbits the Earth once approximately 1 month. This is correct. D. The Sun orbits the Earth. No, the Sun never orbits the Earth. It is the Earth that orbits the Sun. 39. Stars are powered by nuclear reactions that release energy. Which statement describes the nuclear reaction in a stable star? In a stable star, fission is nothing to do with the formation of the star. Fission is the explosion or the splitting of the uranium. So star, it is about fusion, which converts hydrogen into helium. D is the answer. Number 40, a galaxy is moving away from the Earth at the velocity of 3,000 kilometers per second. What is the distance between the Earth and the galaxy? Wow, this is related to speed of the galaxy, which is directly proportional to the distance between the galaxy and the Earth. Right, so speed is equal to Hubble constant times d. D is the distance that I have to calculate. So the speed is 3,000 kilometer. You have to convert to meter. Is equal to Hubble constant 2.2 times 10 to the power negative 18 per second. D. So D is 3,000 times another 1,000 divided by 2.2 times 10 to the power negative 18. You will end up getting 1.36 times 10 to the power of 24 meter, and you can round it off to 1.4 times 10 to the power of 24. So that's a wrap for your May-June 2025 paper 22. So thank you very much for watching, and I'll see you in my next video. Bye.